Hello guys, welcome back. In this class, we'll try to solve these questions. What is the first given question is that I explain about the even and odd parity error checking. What is this drawback, right? So here we need to find out first what is the drawback of even and odd parity method. Error checking means the moment we receive the code at the receiver end, we need to find out whether the received information is correct or not, right? By using odd parity or even parity mechanism, we are going to find out. First we'll see that what is the drawback, then you will be understanding, right? Suppose for example we have the two things. One is the transmitter part, nothing but source side. Another one is the receiver part. Suppose for example here I am using the even parity method, so I am sending this information from transmitter to the receiver. Suppose the code is something received like this 101010, right? So what is the method we have used at the transmitter part? Even parity method we have to use. Even parity means just you count the total number of ones, that should be even. So just count how many total number of ones, 4 ones. It is the even parity we have designed at the input side. That information we are sending to the receiver side. But what is the information we received at the receiver side? Just count the total number of ones, 3 ones. No, it is error or error free. It is error code. Error code means the count is not even number. According to the even parity, output should be even. Here if you feel that, you should not compare this transmitter code to the receiver code word, because in real time what will be happen means the receiver does not know anything about the transmitter section. Remember this part you don't know. Even though you don't know, if you receive this code, you need to be able to find out error or error free. Now we'll come back to what is the drawback means. Suppose the same code I am sending one more time. The received code is something like this 100001. Now you tell me whether the received code word is correct or not. According to the even parity, the received code word is 2 ones, right? 2 ones means even number, right? But the received code word is correct, right? See, you don't know what is the transmitter code is, right? But we have received some receiver code word. By using even parity, we need to find out whether it is our error or error free, right? If you see that what is happening here, the total number of ones are 2, nothing but even parity. It means that the received code word is correct. But if you try to check with this input code with the output code word, it is completely wrong. Now what is the limitation or drawback of even parity odd parity method means? Here in this case, one bit changing means we can able to identify the error. If more than one bit changes, then your even parity or odd parity will not be useful. Those things we need to explain for this question. Now what is the second question? Derive the Hamming code for the sequence. Sequence means message bit means data bit means encode means everything is the same. Now if you observe this is the transmitter code word or receiver code word. This is the transmitter code word. So for this, what is the length of the message bit we need to find out. So by applying 2 power p greater than or equal to m plus p plus 1, we need to find out the number of parity bits required. Then we need to find out this parity bit. Then your solution will be completed. Now what is the next question? SOP function is given, right? Now what we have to do is which variable K-map is required? 4 variable. Why 4 variable K-map is required? Because we have the 4 inputs. Then plot this value, find out the minimized expression. Remember that it should obey the two principles. The first principle it should be, if you are grouping, it should obey the cell adjacency. Then one more thing, remember this is very important point. We need to try to group the maximum number of ones, not the minimum number of ones, right? So next, what is the final question? What is don't care condition? Implement XOR function, right? Some XOR logic gate they have given, something a bar b plus a b bar, something like they have given. So for that we need to design the circuit in terms of only NAND gate. That is the question meaning. So what is don't care conditions, right? So where we are using the don't care condition means the don't care conditions which are used in the K-map representation. In which case, if you don't know whether the K-map cell particular cell value, either it may be 0 or it may be 1, if you don't know exactly, then we used to represent with the don't care combination, right? The don't care combination which are used to produce the simplest output expression in the K-map, right? Now what is the given one more part of this question is that they have given some function. This we need to implement circuit in terms of the finally NAND gate only. So for that, first what we have to do, XY bar means X, Y bar means what is the logic gate we have? AND gate. Then again X bar means again we have the AND gate. Then Y means AND gate. So this means addition operation, right? Now if you see this is the X, this is the Y, this is X, this is Y. Now if you observe here, this is in terms of the basic logic gates. Now this question we need to solve or implement in terms of the NAND implementation only. It means the final output should be in terms of the NAND gates only final outputs, right? That procedure we need to solve. We have the procedure how to convert the NAND representation or non-representation, that we need to apply. Then we need to find out the answer, complete circuit diagram in terms of the NAND gate only, right? Thank you.